Well, good afternoon, everybody. So we've got something new on the test wall today. This is the NHX-10K hybrid inverter sent to me by Watts 24/7. Ian sent this over to me for my review. So let's take a look at the specs and see if we can get this thing hooked up tonight. This is a 10 kVA split phase hybrid inverter. It has an IP65 rating for outdoor conditions. It has 4 built-in MPPTs at 500 volts and 14 amps each, with a maximum PV input of 15 kilowatts. It's UL listed and comes with a 5-year manufacturer-backed warranty from Watts 24/7. Now the dimensions of this unit: width, including the switch, you're looking at about 19 inches. Height, including the grommets on the bottom, you're at 28.5 inches. And depth, you're looking at about 9.5 inches. And this unit does weigh about 90 pounds. Underneath the inverter, it did come with all these glands, of which I've removed 2 of them so far just to get the conduits in place. But each gland has a protective barrier in place to prevent any water from coming in. You can remove those plugs when you're going to run your cables through. So you can see COM1, COM2, COM3. In the back, we've got PV positive, PV negative. This is our generator port. Our grid port is this conduit here, our load 1, and then behind it is load 2. And then you've got your Wi-Fi communication port right here as well, a grounding stud on the back. Now there are 4 hex head screws, and to remove the lid, you'll just slide up and pull out. And I will admit, I do love the metal case, the curves that it has, the nice sleek look. Looking down at the wiring compartment, now this is pretty tight down in here, but height-wise for this opening, we're looking at a 4¼ inches, and then this does drop down. But when you're looking at it from the bottom to the circuit board, you literally only have about 2.5 inches of space in here to work with. The reason that you can make it work is due to these connection points, which have a push pin style. We'll talk more about those in a minute. So from left to right, we've got our battery terminal connections. They recommend 1 gauge cables for here. I actually have fitted 2/0 on here and it works fine. Even 4/0 I believe would fit on these terminals fine. You've got this plastic cover which keeps the metal away from anything else inside the case. We've got 6 different communication ports in here. This bottom lower one here is for your battery communications. These 2 up here are for parallel communication. This one is used probably for the display. And then these 2 down here are your CT connection points. We've got a terminal block here for dry contacts. These are also being used for your remote shutdown capability. There is a USB port over here. I believe I remember hearing that that is for updating the display firmware. And if we look down beneath the circuit board, this inverter has the capability of handling a maximum solar input of 15 kilowatts in these 4 different MPPT terminal sets. All the positives are on the left side, all the negatives are on the right side. Each PV string can handle up to 14 amps, and the MPPT range is 120 volts to 150 volts. Moving over, this has a dedicated generator input. Line 1, line 2, and neutral. We've got our grid input, and then this has 2 dedicated outputs. So you can have a primary output and then a secondary output. The secondary output is controlled by state of charge. So once you get below a certain state of charge, this secondary output will actually turn off. So it's kind of like a critical loads in your standard load output, and then convenient loads on this secondary load output. And both of those can handle up to 10 kVA output with a maximum of 11 kVA output. And then across the bottom, we have our grounding terminal block. Now this is UL, I gotta read this because I never get these right. UL 1741SA, all options, UL 1699B, and CSA 22.2. So I'm assuming that has something to do with the grid interconnection ability. I'm not quite sure, and I'll just be honest about that. It has a lot of built-in safety features. Again, I want to read these because I don't want to miss any of them. Grounding detection, arc fault protection, island protection, battery reverse polarity, insulation resistor detection, residual current monitoring unit, output over current protection, backup output short protection, terminal temperature detection, output over voltage protection, and output under voltage protection. So a lot of built-in safety features to hopefully ensure that everything is running properly and safely in your home. You can parallel up to 8 of these together. Who would need 80 kilowatts of output? That's nuts. But apparently it can be done. I can't imagine the battery bank needed for that. This has the ability to run batteryless so that you could really just use solar to compensate for loads, which that might be an interesting test to look at. I forgot to tell you what came in the box. The box had been rained on. It was disintegrating. It'd be a nasty looking unboxing. Obviously, the inverter. You got the manual. We have 2 100 amp CT connections for connecting to your grid connection so that you can keep track of power flowing out to the grid, or if you want to set it to a zero export mode so that you're only using power in your home, you can do that. So we've got 2 of those, a parallel cable for paralleling multiple units together. And lastly, you've got your wall anchors for mounting this thing to the wall. Mounting points, there's 2 on top, and then there's 2 behind this wiring compartment back here. So as we take a peek under the hood, as I stated earlier, this is an outdoor rated inverter at IP65 rating. And the only fan that you have inside this unit seems to just be like a general air movement fan. The rest of the cooling is all done through a massive heatsink on the back with some fans moving air over that heatsink, and I'll show you that here in a minute. These load cables over here do seem to be like there's 8 gauge. I can't see a marking on the cables because of where the stickers lie. And then over here, that big blue cable that's labeled grid looks like it might be a 6 gauge cable. And then over here on the PV lines, I see 12 gauge labeled on those, and nice neat wire management being done on those. These bus and boost terminals look to be utilizing 12 gauge cable. So all in all, it looks like a pretty neat build on the inside. I mean, look at all these different relays in here. Wow, that's a lot. But it seems to give you a lot of different functionality on what can do what and when. So here's that massive heat sink that I was talking about for the cooling. All the cooling is done through the back of the case. And then air is drawn across that heatsink by these fans on the side. I'm kind of anxious to get this thing online. I want to see how well it works. So I've got my cables ready to go to get wired in, but they're not wired in yet. I want to do that together. So the 2 battery terminals, you can pop off the battery cover. I use a 5/8 socket to pull the bolts off. Positive is on the left side, negative is on the right. The maximum charge current on this unit is 190 amps, and the max discharge is 210 amps. The manual says that the battery terminals are 24.5 Newton meters, which is about 17.5 foot-pounds. So that's what I have my torque wrench set to. seems like a lot, but not too bad. Now, I'm not going to use both the AC outputs right now. I'm only going to set up the load 1 and then the grid connection. And the manual recommends using 8 gauge wire. You can get 6 gauge in there from what I've been told in these little push pins, but it's very, very tight. And you can't get 4 gauge in there. I tried. It won't slide in all the way. So as I stated before, this is tight in here, but these push terminals are really the saving grace, which allows you to fairly easily get your wire connected. So you really are just going to push your cable into these appropriate slot while you have a flat bladed screwdriver and you push this spring release button in. So you'll push that in, slide your wire in, and then release, and it's going to pinch down, pretty much going to pinch down on your wire just like this. And it's going to pinch and hold it in. And you should not be able to pull it out. And don't use solid line. It's the only thing that I had of this gauge. It's a pain. And if any of your wire is a fine stranded wire, the manual recommends to use ferrules. So this is the grid connection. And this block here, this larger block, is the grid block. So you've got L1, L2, and neutral. So L1 is black. You need to make sure that your wires are pretty well flattened together. So I'll slide my cable in there to get it started, and then I will push in with my flat bladed screwdriver and push in the wire. And when I remove my screwdriver, this black cable is now bit down and pinched in place into my line 1. So then all you do is you repeat for all your additional connections. And then on your grounding bar, you'll use a ring terminal to the ground bar. All right, I'm going to be perfectly honest. It was tight getting these ones in here. It was a whole lot easier to get this load side in when I wasn't going around a camera. And I think a little tip that I realized after the fact is work your way from the right to the left, because that way you have a little bit easier time trying to get things into the terminal and putting a screwdriver on that push pin than if you do what I did. I try to do the AC in first, and then I'm trying to get stuff in here on load 1, and it's super tight just because I'm having to fight with these wires. So just a tip, but we've got our load 1, we've got our line, we've got our ground line. I'm not gonna mess with the CTs right now because I need to figure out how I'm gonna route them. But I wanna power it on and see if it works. We'll use it as an off-grid style test just to power it on and see if it does a load. So looking at everything, DC connected, AC in, AC out. I have a 60 amp breaker on my output. The manual actually recommends 63 amp. I'm guessing it's some outside of the US thing, the standalone 63 amp breaker. And we need to pre-charge the capacitors in the unit because we don't want anything going as soon as we turn it on. And then, as always, I recommend before you go to actually flip any breakers on to supply power to devices, you need to test and make sure that everything is outputting properly. And she's powered on. I think it'll be in like a standby mode, I'm assuming. And here's a look at the display of the inverter. This is a touchscreen, by the way. I don't think I said that. Ooh, 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 ooh. We've got one of these things. Oh, yeah. So you can tap on individual icons to get information about each component. You've got PV, battery, loads, grid, and generator. And then up here on the left, you've got your settings. The default password is 5 ones. Okay. So we'll have to go through the settings here. This is all the defaults, which is partially why I don't want to go through and turn on any grid connections yet. because I don't want it trying to backfeed loads or sell anything back to the grid. But I think I need to set the battery. Oh, nope, the battery is already set to lead acid, which is good. And then this bottom right-hand corner, this button is the save button to push the change to the inverter. Oh, that's right, there's an over button. So here's all our battery settings, 52. So it thinks that the battery capacity is 100 amp hours. So we will set that to, what is it now? 790 is what my current setting is. Okay, 790. If I want to set the same values that I have on my other system, absorption 55.2. Okay. Float 53.6. Okay. And the over voltage, we'll leave that as is. Okay. Time is correct. Date's correct. Distributed by watts 24/7. Alarm section across the top. Looks like a few lines could be backed off on the GUI. All right. Let's see if it works. So this is in standby mode. So we'll come over here, this red button on the side, it says RSD button. That's for the remote shutdown, but it's also the inverter button as well to turn the inverter on. PV switch, which I forgot to mention, by the way. That's nice having a disconnect switch. That's in off state right now. Doesn't matter. There's nothing there. So we'll press this button. We wait a few seconds for, I'm assuming, a click. It's so quiet. Oh, one fan turned on. There's our click. So the one fan that turned on is that little one that's up here that just moving air over the circuitry. I don't think it's actually doing any, can't be doing any real cooling. I'm trying to look on the display and see if there's any visual indication that it's inverting. I honestly don't remember. So if I tap the load, now it says 240 volts, 12.5 kilowatt hours. That should have been gone from a reset. So I'm going to come down to my terminal block in here on the output side, and we have 240 volts on the output side. Awesome. My input side, nothing. We don't have any input connected yet. Now, I don't know if you can hear that little fan that's going. So from 2.5 feet away, 40 decibels. But let me show you something that I found out. With that little fan going, he put this faceplate on and that sound just almost completely disappears. That lid makes it, drops it down by 4 decibels. Yeah, it's like a computer fan sound now when this lid's on. So before we do anything else, I want to see what the inverter idle load is when the system is not turned on. It's just in standby mode. So if I turn it to DC amps, zero it out, let's say 0.36, 52.4 volts, 52.4 times 0.36. So we got 18.86 watts in standby mode with it doing nothing. It's just the battery powering it. Let's say 1.48, 1.46 at 52.4, 52.4 times 1.46, 76.5 watts, which I believe is right around the spec of what this should be for idle consumption. So that's good to see. All right. Let's turn on our output breaker over here and then turn on switches for our outlets down here. And we will grab our tried and true vacuum cleaner for the test, just to make sure stuff works. And contact in 3, 2, 1. We got power. And looking at the inverter display, 1.2 kilowatts, going to the load. 1.2 kilowatts coming out of the battery. Oh, so the screen does have a little sleep mode. That's kind of nice. I didn't realize that. So if I tap that, we can now see 1200 watts of power going out. It doesn't tell me the individual legs, which that would be kind of nice if it did. I don't think any other fan kicked on the whole time. I'm gonna try again. Oh, these fans are running, but I just can't hear them because of the vacuum cleaner. Maybe those fans were on the whole time and I just didn't realize it. Well, I did get my temporary PV connections pushed in, but then I realized it's nasty and rainy outside, so there's not going to be any PV anyways to get that hooked up. Plus, I have to reconfigure my array, so we'll try to get that in for the next video just to see how it's doing production-wise. So overall final thoughts on the NHX-10K inverter. I mean, without having gone through and put it through its paces, we got it set up. We did an initial test. It's quiet. I like that. I like that it's a 10K all-in-one unit. As we go through and do a load test and try and take over the house loads like I have with the EG4 6000 XP and the Victron 5 kVA system. This is supposed to handle imbalance a little bit better on the legs, so we'll see how that plays into things. It looks beautiful. I do like the sleek design. It was heavy trying to get it hung up on the wall. I mean, 90 some pounds, I think I said. I like that it's rated for being outdoors. I mean, unfortunately, mine got a little damage here on the bottom. It's not going to affect any of its tests. It kind of bent in part of the wiring section, so I really don't want to test it outside because of that damage. But functional wise, for everything else, it should be fine. I like the touch screen. I mean, I'm used to, on some of these displays, it just looks like it wants to be touched. So I'm glad that it's a touch screen. I think that some of the touch points could be expanded a little bit. You just have to find that right spot, though, for the click to actually happen. There's a couple spots that it seems like it might be a little too small. I was surprised. I mean, I think I had seen reviews on this, but I was surprised to see that it has both the generator and a grid input. And then it's got the two separate loads as well, to where you can have those critical loads on load 1 and then those convenient style loads for load 2. So I might have to get in and I don't know, wire something up just to make sure that the load 2 aspect works. Maybe I'll just put a light bulb or something. I don't know. I'd like it if there was a little more space to work down here. I think I've been spoiled by some of these other inverters that have more space to work with. I mean, even another inch. I mean, obviously I would love, a lot more space, but another inch or two would be nice to be able to, get your hands in there a little bit better. The push pin style connectors do make it work. It's just it's a little tight. I mean, for me trying to fight around the camera. I like that it's got 4 different MPPT inputs as well, because that really lets you truly have an all-in-one system. You don't have to have, 2 strings coming into here, but then, well, if you need more, you've got to add an extra solar charge controller. No, you can do 4 at up to 500 volts apiece. So that's nice to see. So yeah, I mean, all in all, I'm excited to put this thing through its paces. I can't guarantee that videos for the NHX are all going to come in sequence, right after the other, because I've got lots of stuff going on, lots of stuff that hasn't even been talked about yet, going on behind the scenes. So we'll just have to see how the cards fall. But I want to get some mileage on this thing and see how it does. So yeah, lots to come, lots of testing. So hopefully you enjoyed this. It's fun bringing people along on these different installations, the setups, how does it work? How does it look? How does it feel? I like to see how things work. I like to test things. I like to I mean, it's playing for me, really. So with that, I'm gonna let y'all go. Y'all stay safe, stay cool, and we'll catch up with you later.